Good afternoon, ladies and gentlemen. I trust everyone is well. I'm sure you all know by now, my name is Charles Scott from Civil Designer Software. Thank you very much for allowing the time to join us today for the final of this 4-part Civil Designer Software version 8.5 mini series launch. As promised, after today's webinar, the version 8.5 download link will be emailed to you from our CRM cloud system. In the first webinar 3 weeks ago, we covered Civil Designer's built-in, integrated, internal 3-dimensional visualization, which allows for the real-time comprehension of vast amounts of consolidated live data, enabling the easy identification of possible design issues, improvements, and the communication of the design itself at any stage to all project role players, technical and non-technical. In Webinar 2, Week 2, Andrew demonstrated Civil Designer's ability to share meaningful data with the organizations and different engineering specializations that you collaborate with via Civil Designer's advanced IFC export capabilities, as well as the many other file types we read and write. And then last week, Chris presented how, in the same application, all types of project drawings can be created, customized, generated, published, and managed directly from Civil Designer's databases of live design information, thus guaranteeing the accurate presentation of the design team's work, allowing for more design freedom. Trust me, it was a busy 3 weeks, with this week, week 4, being no different, which brings us back to today's presentation, where we welcome back both Andrew Cole and Cameron Boyle, who will be covering the new functionality included in the Roads module. During their time today, please feel free to use the text chat service on your GoToWebinar app or web page to ask us any questions you may have. After today's webinar, we'll post a video copy on the website in the webinar section. So, good afternoon again, gents, and Cameron, please take it away.
Thank you very much, Charles. Good afternoon, everybody, and welcome. As Charles mentioned, today I'm going to be focusing in on some additional roads functionality that I didn't show in the very first 8.5 webinar. There are numerous functions that I want to show you. We'll start off with this project, looking at some very impressive visual design enhancements, and then move on to the second project for more complex functionality. In front of us, I'm going to show you the real-time junction previews for cul-de-sac and mini roundabouts. We will also look at the enhancements to the junction contour labeling functionality. I'm going to start off with this real-time junction previews for cul-de-sac. As you go and specify the different cul-de-sac types, you can see that the preview dynamically updates. If, for instance, you would like to go and change a radii of your cul-de-sac, automatically the preview will be updated. So straight away you see what the end result would look like. In addition to the cul-de-sac types, we have now included a hammerhead type. Having selected that and taken full advantage of the new real-time preview, as I go and make changes to my dimensions of the cul-de-sac, you can see what the end result looks like. Clicking on OK and letting Civil Designer do the hammerhead design within a couple of seconds. Moving on to your mini roundabouts. If you're thinking that the center island is too small, I tend to agree with you. Let's go and make changes to it. Changing my radius of my island. Seeing what the preview looks like. The lane widths are too wide. So I'm going to go and make that a bit smaller and see again what the end result would look like. Clicking on OK and letting Civil Designer recalculate for me. Moving on to the next function. In Civil Designer 8.5, we've enhanced the way your junction contours are displayed. I'm going to show you the same project in 8.4 first, and then we'll compare it to 8.5. Going to the 8.4 screen grab, you'll see that the contour labels actually overlap in the junction areas. Let's compare this to the 8.5. Going back into Civil Designer, going to our display settings, you'll see that the road contours now has its own dialog, and I'm using the same settings I did use in 8.4. Click on OK. Just taking a quick sneak peek at the 8.4 contours again, you can see the difference. The last function I want to show you within this project is a simple road strings ASCII export function. In this case, you need to go and select the road you want to export the string CSV file from. Go and right click, select road operations, write string to a CSV file. Done with this project for now, moving on to the next project. With this project, I'm going to start off with the horizontal alignment functionality. In 8.5, you are able to handle CAD entities with multiple curves in sequence. I've already gone and created a road, and using this CAD polyline, I'm going to use the regression functionality and pick up the horizontal alignment. In 8.4, you weren't able to use multiple curves in sequence. As with 8.5, you can now do so. Going to Alignment, Regression, Extract Alignment. Selecting to extract the horizontal and the vertical in this case. Clicking on OK. Picking up the polyline as my CAD entity. And then extracting different intervals for my straights and my curves so that you can see the difference. Specifying your cross-section extraction, and then just taking note of the intervals of your cross-section. From this, we can see the multiple curves in sequence. Having a quick look at the horizontal alignment, you will see in 8.5, Civil Designer automatically puts in very tiny offsets between the ECC of the previous curve and the BCC of the next curve. Looking at the next function, the automatic lane widening at curves. Curve widening in horizontal alignment design is normally utilized for off-tracking, which is more pronounced for trucks, where the vehicle's rear wheels track inside or outside the front wheels. The amount of off-tracking is dependent on the curve radii, vehicle speed, super elevation, and size of vehicle. Take note, our newly selected road currently has a width of 2.25 on both left and right hand side. While I'm here, I might as well show you that if you right click in Civil Designer 8.5, you have an additional function of CSV file settings. Here you are given the option of specifying which delimiter and which decimal separator to use. Now let's take a look at the actual function. It is found by going to Alignment, selecting Design Criteria. The Use Design Criteria doesn't have to be selected, but you do need to select the Use Curve Widening option. Once this is selected, you can click on the widening settings. This dialog gives the widening type of inside, which in this case will be applied to this side of the road, the outside option, which will then be applied to the opposite side, then of course the option of both. If your road has transition curves, the full widening will be applied to this specified customizable percentage. A maximum width is useful in restricting road reserves. 3 widening methods ensures that you are not limited to choice. As you select which method to use, the applicable below cells are made available for customization. I'm then going to select the widening table option to discuss this in more detail. Within this design criteria dialog, you will find additional 2 tabs here. The one being the sight distance, which I covered in the very first 8.5 webinar. The second being this curve widening tab. Here you can customize your own radii, inside and outside additional widening, as well as your very own inside and outside transition lengths. Alternatively, if you are in possession of a design standard, you can simply right-click and select to use a CSV file of choice. Your file is loaded and ready for use. Even though we make provision for outside widening, it's not compulsory. All of these values can again be adjusted. Click on OK. In order for these automatic road widths to be implemented, I'm going to click on the Recalculate button and regenerate the new edge widths. Looking at the results, let's zoom in. The transition length was 33 meters, so it's a rather smooth transition. The additional widths are applied to the inside curves as specified. Changing my zoom view, let's take a quick look at the design. I'm going to select the road so the BCC is indicated. Going to the CAD mode, I'm going to switch on the geometry lines that I'll also utilize for the next function. Back in the roads mode, changing back to the automatic curve widening settings. This PI has a simple curve radius of 60 meters. Therefore, we are utilizing this first row of information where anything up to 80 meter of radius will have an inside transition length of 33 meters. When using this widening table, as in this example, the transition length is measured before the BCC. At the BCC, in this case, the additional full width is achieved. Moving on to the next function. Looking at compound curves, many of our clients utilize compound curves at on and off ramps. They use these compound curves to slow the vehicle down somewhat before implementing a sharper curve. Selecting our active road to show you we are working with HPI 12. I have beforehand put in geometry entities for explanation purposes. Eventually our HPI will be closer to these geometry circles. Taking a look at the existing horizontal curves, HPI 12 has a simple curve radius of 150. If we change the simple option to a compound option, the original radius information is grayed out and we are presented with a new compound curve dialog. Typing in my new radius of 100 and specifying it to be a floating curve. You always need at least one floating curve. A floating curve implies that Civil Designer will automatically calculate the curve length to retain the tangency of the HPI tangents. As it is now, it is pretty much the same as a simple curve. So let's right click and add an additional curve. Specifying a radius of 70, I could put in a curve length, but for now I'll also make it a floating curve. I have the option to insert a curve in between. You can insert numerous amount of curves. Alternatively, you can go and right click and select delete. Closing the horizontal alignment and recalculating. For compound curve explanation purposes, I have created two CAD layers. Looking at the floating option first, all curves are concentric curves. We'll take a look at the first curve's curve length in the properties bar. The curve length is 104.5 meters. Also take note that the road embankments are very close to the end of our survey. Let's go and make a change to our design and make one of the floating curves a fixed curve length. Changing my CAD layers, switching off the floating option and then turning on the fixed option. Going back to PI12, compound curve, switching off the first curve floating option and then specifying a curve length of 120. Closing the horizontal alignment and recalculating. Let's take another look at the new curve length in the properties. We can see that it's been updated to 120 and the road embankments fall within our survey. Moving on to our last function, looking at the cross-section editor function to add fill benching. I'm going to start off by duplicating the road ground layer. This will assist to understand how the benching is calculated. Then going to Section, Graphical Edit, and selecting the position of our cross-section. Magnifying into the cross-section, if you now right-click in Civil Designer 8.5, you have the option of Add Benching. I'm going to first start from the top. In the next example, I'll start from the bottom to show you the different options. Pressing J on the keyboard, I can jump to specific start and end points. Having a look at this new dialog, the diagram indicates which dimensions you can customize. The width in this case is grayed out due to the width being determined by the ground intersection. Click on OK. This displays the new benching that has automatically been created. Now let's do the same function, but this time starting from the bottom, working our way up. Changing my cross section without saving, and then reverting back to the same chainage. We right click, select Add Benching, starting from the bottom this time and then working our way up. You can see that in this case the bench height is grayed out, and that is again due to the height intersecting with the ground level. Looking at the final product, thank you very much for joining us. If you've got any additional questions, please do let us know. Until next time, cheers for now. Back to you, Charles.
Thank you, Cameron. I'm now going to hand over to Andrew for his portion of today's presentation, where he'll be covering the turn and roads modules. Andrew, please take it away.
Thanks, Charles, and welcome to my section of the 8.5 launch webinar. For the release of Civil Designer 8.5, our developers have made some nice improvements to the turn module. For turns dynamic vehicle simulation, the positioning of the vehicle along the track path has been made more interactive and graphical. And the maximum steering angles can now be monitored all the way through the simulation. As you can see from this dynamic simulation, you'd now be able to view the vehicle's position during the simulation as well as the vehicle's track path in real time. You will also have noticed that we've added a directional arrow which indicates the direction of the vehicle's main steering wheels. When the vehicle's maximum steering angle is exceeded, then the arrow turns red, and the current steering angle, which is always visible up in the prompt bar, also turns red as a warning that you're exceeding the maximum steering angle. The actual simulation and saved track path are still run afterwards and saved to your specified CAD layer. So to illustrate how it works, let's have a look at this passenger vehicle's turn simulation. The default passenger vehicle's maximum steering angle is set to 34.7 degrees. When running the dynamic simulation, you need to set a start point and the initial track direction, and then click to define any change of direction point, or waypoints as we call them. You can see that when I move the wheel angle past the maximum steering angle of 34.7 degrees, then the arrow turns red to warn me that I'm exceeding the maximum angle. For all practical purposes, you wouldn't want your vehicle to exceed its maximum steering angle. And to prevent this from happening, you can then select to enforce the vehicle's steering angle limits in the turn setup dialog before running a simulation. If I then run a dynamic simulation again with the enforced steering angle limits activated, then the vehicle won't be allowed to exceed its maximum steering angle during the simulation. I'm just clicking to define the waypoints, but you'll see the simulation is not allowing me to exceed my maximum steering angle. So you can now define the path your vehicle needs to take dynamically and have the arrow and angle indicator to assist you in defining the correct path. If you right click, you can then also have the options to cancel the last waypoint and go back a step. You also have a 4 straight option, which then locks the wheels in the straight ahead direction. The vehicle will then continue on a straight path when clicking ahead along the path. So some nice enhancements to the turn module for Civil Designer 8.5. Okay, then moving on to some additional functionality that's been added to the add-on strings, the road add-on strings. You can now pick up the levels, plot the levels in your cross sections, the add-on string levels, and the add-on strings are now dynamic. So as you make changes to your road, the add-on string will then be recalculated and draped on your road surface. Okay, so I'm just going to run through that quickly. I've got a polyline where I want to position my add-on string island. Going to run through the adding of the add-on string from polyline. Just checking that it's the correct road. So good, yes. Selecting the polyline. Okay, so you've got a cross-section ID, your parent string for the add-on string. So I'm going to make that 123, the code, ID code. And then I'm also adding a back of curb cross-section ID code of 124. Just select the curb. Okay. Okay, so we're generating the island. Okay, let's look at that in the cross-section. Okay, so you can see the add-on island that we've got. Okay, so we want to be able to plot that in our cross-sections. So I'm going to go to my sheet file firstly and just show you the annotation. So it's under settings, sheet file settings, your cross-section annotation. So just the standard cross-section sheet file. I've added some additional entries over here. So picking up elevations from my design layer. And I've used the code 123 for that parent string, front of curb. So it's elevation I'm picking up and offset. The horizontal position would be directly below the position of that add-on string, the curb in this case, and then the vertical position over here, I'm picking it up at the actual add-on string. The offset I'll put vertically at the actual offset line in the details section. So that's 50 millimeters below. It's gonna, for illustration purposes, let me just change these colors. So making the elevations red and the offsets blue, so we can just see exactly where they are. Okay. So the actual positioning of the level at the exact edge of curb or back of curb is the E option over here. And just importantly, you also have to make sure you're allocating an ID as the positioning option. So IDs for all of those. Okay, and I'll just save that. Go back to my design. Okay, and then I'm going to run that cross-section plot. So plot generate, cross-section sheet file. I'm just going to do a section, smaller section of the road where that island is positioned. Okay, and then we can zoom in there. So you can see the offsets over here on that offset line, and then the actual levels. So front of curb, that would be that 123 ID. Back of curb is the 124 ID that I used. Okay, so very useful that. And then the other thing is the road that dynamically updates. So if I look at that in the roads again, my cross section, to show you the road is in a little bit of cut. So what I'm going to do, I'm going to change my vertical alignment on that section to show you how that would update then. So I'd go to my alignment, vertical edit alignment, and we right here near the start of the road. You can see the crosshair. So I'm going to move one of these vertical PIs a little bit higher. Okay, so now if I have to look at the section over here, you can see the add-on string has also been updated dynamically. And if I look at my plots, you'll see that those levels have also been adjusted. Okay, so the add-on strings are now dynamic as well. So very nice improvement for Civil Designer 8.5. We've shown quite a few enhancements to the auxiliary services for Civil Designer 8.5. So I just want to point out one or two additional enhancements that we haven't touched on yet. We've added additionally a slope over here, so you can actually specify a fixed slope, and you'll notice that the downstream invert level then updates once it's read in and changed the slope. You've also got a category that you can assign, which would then be included in the IFC export file. Okay, and then we've also made some enhancements to the display settings. We've brought this more in line with the sewer, stormwater, and water display settings. So just a few additional enhancements to the auxiliary services. Okay, then let's have a look at the enhancements to the linear road furniture functionality. In Civil Designer 8.5, we've added the ability to use a curb profile to create your linear road furniture, in addition to the existing block profiles that can be used. To show you how this works, I'm going to add a new linear road furniture item to the file and then add a curb to my terrain platform. So just clicking on the add button to add a new linear road furniture item and naming it BK1 plus channel. Any curb in your curb library files can now be used for your linear road furniture profile. Okay, so I'm just looking for a curb file to use in the knowledge base software folder, just the default curbs folder, and then in the Vanstone curbs folder. Importantly, you would need to change the file of type in this dialog to a Caribe curb file type. Okay, and then I'm using those combination curbs. At this stage, you would have to use the block selection to specify exactly which curb you're going to use for the panel or profile shape. You can also set some horizontal and vertical offsets to offset the furniture from the line that you use to define the path along which the linear road furniture must run. Okay, and then saving this newly added linear road furniture item to the default sample linear road furniture file. Okay, I'm going to use the signage add linear road furniture function and selecting my newly added barrier curb and channel linear road furniture item. I'm using the start and end point option to define the start and end point of where the road furniture needs to be inserted. So selecting the line and then the start point, I've just got a polyline drawn around this parking area. So as I move my cursor with the start and end option, you can see exactly where the linear road furniture is being inserted. Then if I zoom in here in the render view, you can see that barrier curb and channel linear road furniture item has been added all along the edge of my parking area. So that's on top of a terrain platform surface. So making it a bit easier now to add those curbs to your designs. On the survey and terrain front for Civil Designer 8.5, there have been numerous function and dialogue enhancements. One of them being a function that one of our loyal clients has requested, and that is the option to export a DTM surface to a TIFF dem file. So that would be under the file export options and this new TIFF dem option. A TIFF dem is an image file where the color of each pixel is an elevation, and these files can be used in various software packages. Okay, and then just naming the GeoTIFF file. Then you get to select which surface you want to export, and then two options as far as the grid spacing goes, a 1 meter grid or a 10 meter grid, so slightly more coarse grid. So I'm going to stick with a fine 1 meter grid. Just runs through the GeoTIFF export, creating that TIFF image. Okay, then just having a look at the actual file, the TIFF file in File Explorer. If I double click to open it up, you can see it's just a normal image file that was created. Okay, and then let's import that file just to see what that would look like. So we can also import TIFF dems into Civil Designer. So that's under the file import options, the TIFF dem file. Just selecting the dem export that I've just done. Just going to put it onto Surface 5. And then let me just switch off the visibility of Surface 1, my DTM. Okay, then just zooming in nice and close over here, you can see that is that 1 meter spacing. If I switch on the elevations, as you can see, interpolating elevations from the triangulation from the original surface. Maybe just have a look at that in the render view. You can see the densification of the point data. Okay, so that's your TIFF dem file. And that's all I've got time for today. Until next time, cheers.
Thank you, Andrew. And thank you very much to all of you who took the time to attend today's final launch webinar, and to the long list who attended the entire webinar series. We place a very high value on the loyal support and input we receive from you, our customer community and industry partners, as it is your collective feedback which drives our customer support development model. So, we're looking forward to doing this all over again for the next version. I would also like to thank Andrew, Cameron and Chris for your presentations over the last 4 weeks, and last but by all means not least, David Atoy and his team of software developers. Please look out for your version 8.5 download link email, which will be landing in your email boxes soon. Please also feel free to email us right now if you just can't wait. See you all again on the 25th of November when the regular Open Classroom series resumes. Thank you once again for your time today. Have a great afternoon, weekend, and goodbye for now.